Good morning, dear students. In the last video we have seen about distance and displacement. Now today we will see about the state of a moving body. In the very first video we have seen the state of a body which is in rest or in motion. Now here we will see the state but of moving body, not only a body. A body which is in motion. We will discuss the state of that motion. So, the moving body will undergo the motion. Either the motion will be uniform or non-uniform. Uniform, that means similar. When you come to school and when you wear uniform, you will look around. Each one of your classmates will be in the same type of clothes. That is called uniform. And now at present when you are coming to the school, you are not in a uniform. That means non-uniform. Same thing in a similar manner when motion is considered as travelled in a same interval of time and same distance, then it is uniform. And when the interval of time is not similar and the distance travelled is different for each interval of time, then the motion is non-uniform. So let us first discuss about uniform motion in a proper manner. A body is said to have uniform motion when it travels equal distances in equal interval of time. If the equal interval of time is there in that interval of time, that means from one consecutive time to the another, to the next, the time remains the same, that is equal interval of time. And at each equal interval of time, if the distance travelled by that body remains the same, then it is called uniform motion. Let us see here an example. Suppose a body here, this upper values are time and this lower value shows the distance. 0 second, 1 second, 2 second, 3 second, 4 second, 5. You see each time the consecutive value increases by 1 second. And here first is 0 meter, then 10 meter, 20, 30, 40, 50. What do we see here? Each consecutive second when increases, the distance travelled also increases by the similar magnitude. 0 to 10 meter, 10 to 20, again 10 meter, 20 to 30, again 10 meter, again one more 10 meter, 10 meter. So time increases is 1 second each time and distance increases 10 meter each time. It means in equal interval of time, the motion, that is the distance travelled by a moving body, is equal, and such type of motion of the body is termed as uniform motion. Here at each increasing consecutive 1 second time, there also increases the distance by 10 meter each. So a body moving with a constant speed, this is an example, body moving with a constant speed is said to be in uniform motion. And non-uniform is little different there. A body is said to have a non-uniform motion when it travels unequal distances in equal interval of time. Time interval remains the same. 0 second, 1 second, 2 second, 3 second. So time interval remains the same, but the distance travelled from 1 second to the next, consecutive increasing seconds. Consecutive, that means 1 by 1. So 1 by 1 increasing the time, the distance does not remain same as this. Here each time increase of 10, each time 10, then 10, 20, then 10, 30. You can see equal time, equal distance. But now here we can see time is 0 second, 1, 2, 3, 4, 5, 6. So time consecutive is similar, 1 second increasing. But here see at 0 second body is at 0 meter, then at 1 second it is at 1 meter. So now at 2 seconds it should be at 1 more meter. So 0 to 1, 1 to 2, 2 to 3. But here at 2 seconds it is at 3 meter. So you can say 0 to 1, so 1 meter increased. But now from 1 to 3, so 2 meter increase. Now at 3 seconds it is 4.5 meter. That means from 2 it is now increasing 1.5 meter. At 4 seconds it is, you can see, 8 meter. That means from 1.5 directly now it increases 3.5 meter. Then 4 to 5 seconds, 8 to 9 meter, so only 1 meter increase. 5 to 6 seconds, it is now 11 meter, so 2 meter increase. So here we can't see the increase of the distance similar. In the earlier it was 10, 10, 10 meter each time. Here it is 1 meter, then 2 meter, then 1.5, then 3.5, then 1, then 2. So it is not similar, not uniform. So at each interval of time that is increasing, each case of the time, the distance is not certain. That means not similarly fixed. And such type of motion by a body is termed as non-uniform motion. So on the basis of uniform and non-uniform motion, now one more physical quantity which we will discuss is speed. Normally we always use this word speed, which gives the idea about how faster the vehicle is, right? So the speed of a moving body tells us how fast or how slow the body is moving. With help of the speed we can know that how fast the body is or how slow the body is moving. What we can say in an exact physical manner, the distance travelled by a body per unit time over a short interval of time is called its speed. For a specific time of interval and for that uniform interval of time, whatever the distance travelled is termed as speed. The distance travelled by a body पर यूनिट टाइम, मतलब अगर कोई एक फिक्स टाइम दिया है, उसी टाइम में जितना बॉडी ने डिस्टेंस ट्रैवल किया उसका जो हम रेशियो लेते हैं दैट इज टर्म्ड एज स्पीड. Speed can be expressed in the formula like this. Speed is equal to distance travelled in a short interval of time divided by time interval. And speed is denoted by a curve V. Right? You can see here small alphabet V, but that too in cursive writing V. So this is the symbol of speed. How it is measured? Distance travelled in a short interval time upon time interval. We can say that the ratio of distance travelled by a body in a specific time, that is termed as speed. If we consider speed, then speed needs magnitude or measurement. To describe speed, we doesn't need any specific direction. Distance travelled in a respective time is the speed. So there is no need of any specific direction, and that is why speed is scalar quantity, as it has only the magnitude, that is only the measuring quantity. If a body covers a distance is equal to s, symbol of distance, in time t, symbol of time, then speed, cursive V is the symbol of speed, is given by speed is equal to distance travelled as by time taken t. S by t is the formula to find out speed. Whatever distance travelled, that is s, divided by the time given, that is t, we will get distance travelled by time, that is the speed. So what could be the speed unit? Speed's unit is expressed in terms of distance travelled and time taken, because speed is distance traveled by time taken. So the unit of speed depends on distance and time. Unit of speed depend on system, that is s, distance, and time t. So unit of speed is equal to unit of distance upon unit of time. Unit of distance, we know the standard unit, SI unit is meter for distance and SI unit for time is second. So meter per second, that is m by s. S is it in the denominator. When we want to write it to numerator, then s is here is only one power, no power written, so s is only 1. So when we write denominator value to numerator, it will be considered s raised to minus 1. So either you write m by s or m s raised to minus 1. It is meter per second. Meter per second, m by s or m s raised to minus 1 is read as meter per second for MCAS system, that is bigger unit system, meter kilogram second, and centimeter per second or centimeter second raised to minus 1 as centimeter per second as CGS system, that is smaller unit, centimeter, gram and second. So I hope that you would have understood about the formula to find out speed. Speed is denoted, is symbolized as cursive V, which is equal to distance travelled by time taken, s by t. It is unit is meter per second, m by s. The speeds of fast moving bodies like car, scooter, aeroplane are generally expressed in the unit kilometer per hour. We normally know that the unit for the fast moving bodies are always given as kilometer per hour, and for the slow moving bodies it is given centimeter per second or sometimes meter per minute. But while calculating the numericals, we will always have to convert whatever the unit given into the standard unit, that is called SI unit, and it will be always meter per second. Right? Now, what is this speed used for? So if we consider, then speed is a comparing quantity. Is it a measuring quantity? But if we know the speeds of different vehicles, if we know the speeds of different objects, we can compare how faster one object is, or how faster the one vehicle is than the another, or how faster this another is slower than the first one. So that is to be understood by the speed, and to compare the fasting and slow rate of different objects, we need to know about average speed. So what is average speed? Average, you know, as a per mathematics, average is a mathematical term which gives the ratio of given total sum of the given observation divided by the number of the observation. That is your average. When you want to know your percentage, you sum up all the subjects' marks and you divide by the total number of subjects which exist as a percentage. Average is little like that only. The total distance of the travel value upon total time will give you the average speed. So let us first understand what is it and where it is helpful. Average speed helps in the comparison between the two or more bodies. As I just told, that if we want to compare who is faster, who is slower, so between two or more than two, if we want to compare, then average speed is helpful to know which one is faster and which one is slower. Here is an example. A motorcycle runs faster than a bicycle. This we all know, right? Because bicycle runs with the muscular force, muscular energy, whereas motorcycle runs with the petrochemical energy. But when the motorcyclist, the one who is riding the motorcycle, motorcyclist applies brakes, when he applies brakes to his motorcycle, think for a while what happens. At the very first, the motorbike will reduce its speed, it will be slower down, and gradually it will come to rest also. So, as soon as the motorcyclist applies brakes, the speed of the motorcycle decreases and it might come to the standstill. खड़ी हो जाएगी. But at the same time, the cyclist will be still cycling. लेकिन जो cyclist है वो तो cycling करता रहता है. So what will happen? Cycle would be faster at that time than the motorcyclist. For that moment we can say that cycle is faster than the motorcycle, because at that time motorcycle is at rest. But if we consider the whole journey from where it has started, the total distance of travel is the whole journey. So at that time, the motorcyclist covers the same distance as cyclist, but in lesser time than the cyclist. So if we consider whole distance or whole journey of both, then it will be to our observation that, to our knowledge that motorcycle will cover the same distance what cycle has covered, but it will be covering in lesser time than the cycle. So from these example, like this, many example you can cite, even yourself you can think, your experience you can recall, and by such examples we can come to an observation, to a conclusion that an overall idea of how fast a body had moved can be obtained by dividing total distance travelled by the total time taken. In the speed we have just considered distance travelled by time taken. But now here I want to know about the total average speed. Average, that means whatever distance is travelled, that is total distance, and whatever the time, total time taken for it, the ratio of these two will give us the average speed. So we can express average speed as total distance travelled by the moving body upon total time taken to cover that distance. That is considered as average speed. That means we can see in another word also that the speed of each moment, each instant, so that could be the average speed. Total distance travelled by total time taken. हर एक इंस्टेंट का, हर एक मोमेंट का जो इंस्टेंटेनियस स्पीड आएगा, हर एक मोमेंट का, उसी को हम टोटल टाइम से डिवाइड करेंगे, तो वी विल एक्सप्रेस द एवरेज स्पीड. सो दिस वाज अबाउट द एवरेज स्पीड and how to now calculate the speed and average speed, that we will